Duvalo, not a volcano. What you are looking at is considered by some to be the only volcano in the Balkans, albeit if we exclude Greece from this category. Here, a strange cluster of degassing vents in North Macedonia have killed large swaths of vegetation and animal life for multiple centuries on end, resulting in a barren patch of ground. And this ground contains abundant native sulfur, with the only reason you don't see more of it being that the Ottomans extracted the vast majority of present sulfur in prior centuries. To the casual observer, this feature, which is known as Duvalo, might initially look like a standard series of geothermal vents associated with an active volcanic complex. There are even small craters in the ground that look like they were formed in explosions associated with volcanic eruptions. However, there is only one problem. If you look around, there are no young-looking volcanic rocks to be found, as North Macedonia does not contain a single active or even dormant volcano. And, as multiple recent analyses have shown, Duvalo is not being fed a combination of tens of thousands of tons of hydrogen sulfide or carbon dioxide gas a year from underlying magma, meaning this phenomenon does not represent the early stage of a new volcano forming or the last stage of a failed magmatic intrusion. Looks can be deceiving, as this geologic oddity native sulfur, in my opinion, best fits the description of a cluster of hydrocarbon fumaroles. You see, native sulfur deposits are not only formed at volcanoes, and while this is not a complete list, but they also can form at certain hot springs and in hydrocarbon deposits. The key to its emplacement in elemental form at hot spring and volcanic environments is both a high temperature and the presence of hydrogen sulfide and sulfur dioxide gas, which reacts to create elemental sulfur using this equation. Yet, no sulfur dioxide gas is emitted at Duvalo, as its gas emissions are primarily a mixture of carbon dioxide and hydrogen sulfide. Instead, I propose that the following is occurring in an anaerobic environment underground. First, note how the various patches of dead vegetation seemingly occur along two regional normal faults and how the largest patch of barren vegetation occurs at the intersection of these two faults. I interpret that underground, some form of hydrocarbon source rock exists. How Duvalo formed, which had deposited some oil and natural gas via a fault trap below an impermeable layer. Since anhydrite is known to exist in the region, I will interpret this as the impermeable layer. I interpret that sulfate-reducing bacteria grew in this anaerobic environment, leading to hydrogen sulfide production and on rarer occasions leading to the creation of some native sulfur. Made acidic by the hydrogen sulfide, the hydrocarbons began eating away at the overlying anhydrite rock, leading to even more hydrogen sulfide production. The gas then found its way to a regional normal fault, rising through it as a path of least resistance, before finally being emitted through several spots on the surface. This killed nearby vegetation, thus creating the Duvalo feature. Opinion: these toxic gases are heavier than air, and as a result pool in low points. It is for this reason that in my opinion, I recommend against going to low points at Duvalo, or bringing children or pets to visit this geologic oddity. As a final note, I would like to thank my new YouTube channel member Marina Grubisa for